Lab equipment overview. This is going to be a little bit of review as to how to properly use lab equipment inside of the science lab. We're going to look at the triple beam balance, the graduated cylinder, the ruler, specifically in this case the metric. We're also going to look at the standard ruler, the meter stick, the spring scale, and the thermometer. So the triple beam balance. Triple beam balance looks like the picture above. It's used to measure mass. The unit of measure is the gram. Parts of the triple beam balance are the pan. This is the area you lay the object that you're going to weigh. The balance or zero mark. You'll notice there's a small zero right there along with a line on the arm that comes out. There are three riders or movable masses. And then in this case, from the top down, it goes tens is all the way to the far back. Then hundreds is the big one in the middle, and then ones are right in the front. There is also a zero adjustment knob, and it's important to know where the zero adjustment knob is if we notice that our triple beam balance is not zeroed. So how to use a triple beam balance? We're going to place the balance on a flat level surface. We're going to move all sliders to the left or zero them out so we know that they're all balanced at zero. Step 3, we're going to determine if the pointer is at the zero mark. If it's at the zero mark, then I can move on to step number 5. If it's not at the zero mark, then I need to complete step number 4. And it's important to do this at eye level because if you're standing up above it, you might get that just slightly off and it might not be accurate. So lower your eyes to where the balance is at and look straight ahead at it so that then you know that you are getting it accurate. Step 4, turn the zero adjustment knob counterclockwise, which will cause the pointer to move upward. And if you turn the knob clockwise or down, the pointer will then move downward. And the knob should be adjusted until the pointer is at the zero mark. Step 5, place the object on the pan that you want to measure its mass. Move the largest slider, the 100 slider, to the right until the pointer falls below zero. And you should feel that that mass or that largest slider kind of click along. And you want to make sure it gets into the proper groove. It will actually click into place. The slider must be then moved one notch back after it falls. The pointer falls below zero. Okay, so you move it one slot back. So you'll slide it over, it'll fall below zero, you move it back one slot. Repeat step 6 with the 10 slider. So you're doing the same thing in step 7 as you did in step 6. You're just going to the 10 slider. You started with the hundreds, now you're going to the tens. Step 8, move the 1 slider to the right until the pointer is at the zero mark. Step 9, determine the object's mass in grams by totaling the numerical values highlighted by the hundreds, tens, and 1 sliders. So looking at the triple beam balance and identifying the mass of an object. The object you can't see in this picture, but we can see the beams that the masses are on, or the sliders are on. We want to know what is the total mass of the object that's sitting on the pan. In this case, we're going to focus in on the back one, the tens slider. And the 10 slider is sitting on 30 grams. So I take 30 grams, and then I look to the 100 slider, and it's at 0, so I take 100 and I add it plus 30. Or I take because the hundreds one is at 0, I go 30 plus 0. And then I've got the ones slider is at 2 grams, so I take 30 plus 0 plus 2 equals 32, so I get a total of 32 grams. The graduated cylinder. Graduated cylinder is used to measure volume. It is a unit. Its unit of measure is the milliliter. They come in a variety of sizes. The value of the graduated markings or lines change with the size of the graduated cylinder. So it's important for you to notice the difference between the different graduated cylinders. You got to pay attention to the markings so that you know what each marking represents. Some of them represent a half of a milliliter. Some of them represent 1 milliliter. Some of them represent 2 milliliters. So each of these lines represents 1 milliliter in this case. And each line is a graduated marking. It is called a graduated marking. The reason that I know it is 1 is because I look at the bottom line there where it's a solid line all the way around the graduated cylinder and it says 50. The one up above is 60. So I look at each one of those lines in between 50 and 60 and I notice that there are 10 of them, 10 lines total. So I know that each number between 50 and 60 has to be a 1 milliliter marking. So we use the smallest possible graduated cylinder so that we get the most accurate results. It's important to use the smallest graduated cylinder so that then you know you're putting the right amount of liquid inside of whatever the experiment is that you're performing. So in order to accurately determine volume when you're using a graduated cylinder, it's important to figure out the volume, or excuse me, the value of each graduated marking. So in order to do that, you have to identify the difference between two consecutive printed numbers on the graduate and then dividing that by the number of lines. So for example, we're going to look at this picture right here. And we need to know what is the value of each line. So I first look at the 80 line because I know that 80 is 80. And then I'm going to count down. Okay, so in this case, the difference between 80 and 70 milliliters is 10 milliliters. If I then count the number of lines, not including the first one, between those two numbers, I get 10 lines. If I divide 10 milliliters by the 10 lines, I should get 1 milliliter per line. So I can go 70, 71, 72, 73, 74, 75, all the way up to 80. That is one way for me to figure it out without having to do the actual math. I can just count it off. The meniscus. The meniscus is the curved line that the liquid makes inside of the graduated cylinder. And this is due to the adhesion and cohesion properties of liquid. Water likes to stick to itself and it likes to stick to other objects. And so what happens is water sticks to the outside edge, or I guess in this case it would be the inside edge of the graduated cylinder. And it kind of rides up where it's sticking to the edge of it. So the meniscus is the bottom of that line that you see. You can see how it's curved. The water line is curved. So if each graduated marking has a volume of 1 milliliter, what would be the volume of the liquid if you read the graduated cylinder from the bottom of the meniscus? Always read from the bottom of the meniscus. Okay, and I know this one is a little bit difficult because the picture didn't come out fantastic. It's a little bit blurry. But I first look at 60. That's my line for 60. The next line is 61. The next line is 62. The next line is 63. So in this case, because the bottom of the meniscus is at 62, my volume is 62 milliliters. So we're always looking for the bottom of the meniscus, that bottom of the curving of water, due to the outside edge of that water sticking to the glass in the graduated cylinder. Alright, so how to use liquids. How to use a graduated cylinder with liquids. Select the smallest possible graduated cylinder that can accommodate the amount of liquid that we're planning on using. We're going to determine the value of each graduated marking or line found on the graduated cylinder. By knowing this, it will help you determine the overall volume. Place the graduated cylinder on a flat level surface, so that's going to be important as well. You want to make sure that you have a flat surface to work from. Carefully pour the liquid into the graduated cylinder without spilling any, and you may need to use a funnel for that. Measure the level of the water by looking at the bottom of the meniscus, and this should be done at eye level. Don't try looking at it up above or down below, right straight across. You should be right at eye level when you look at the meniscus. So looking at this picture, what is the volume of the liquid in the graduated cylinder? Take a look at it, see if you can figure it out. So the meniscus. The meniscus is right there. Since each graduated marking is equivalent to 1 milliliter, the volume of the liquid in the graduated cylinder is 48. So I can just simply count up. I see 40 and I count up each line and I look for the bottom of the meniscus and I can see where it is right at the 48 mark. Water displacement. This is in order to measure an object that maybe has irregular shape to it. So I'm going to use water displacement to do that. So water displacement is a process by which a graduated cylinder is used to determine the volume of a solid object, particularly one that is irregularly shaped. The volume is calculated by observing the amount of water displaced by the submerged object. So first I look at my initial volume of water. I'm probably going to fill it up to an even amount. Like I would put it at 20 or 30 or 40. I'd put it right at an amount that's easy to identify. I would then take the object that I want to measure its volume and I would put it inside of that graduated cylinder, not removing any liquid. So I would take the initial volume and I would subtract the final volume from the initial volume. And notice that the water level rose after the object was placed in it. This rise of the water helps you figure out the object's volume. So step by step, how to use a graduated cylinder in water displacement. We're going to select the smallest possible graduated cylinder that can accommodate the object that you are actually going to measure. We'll determine the volume of each graduated marking or line found on the graduated cylinder. And knowing this will help us determine the overall volume. We're going to fill the graduated cylinder with enough water to adequately submerge the object that is irregularly shaped. Do not fill so much that the water, when you drop that object in, water like spews out over the top of the graduated cylinder. Just put enough in that you can fully submerge your object without spilling any all over. Place the graduated cylinder on a flat level surface. Measure the level of the water by looking at the bottom of the meniscus and record the initial volume. And again, this should be done at eye level. Carefully place the irregularly shaped object in the graduated cylinder. Sometimes you may have to angle it funny direction to get it in there correctly. Don't jam the object in there. If it won't go in, then you probably shouldn't put it in. You should probably use a bigger graduated cylinder. So we don't want anything stuck down inside of graduated cylinders. Measure the new level of the water by looking at the bottom of the meniscus and record the final volume. Again, this should be done at eye level. You're going to then calculate the volume of the irregularly shaped object by subtracting the initial volume, so the measure that we've got from step 5, from the final volume. And that's the measure that you got from step 7. Okay, so in this case, what's the volume of the rock in the graduated cylinder? So we've got our meniscus. We can see it in both pictures. In this case, I start with 28 milliliters. And it goes up to 38 milliliters after I put the irregular shaped rock in it. So I've got my final volume, 38 milliliters. I've got my initial volume, 28 milliliters. I subtract 28 from 38. I get a total of 10 milliliters. So my overall measurement in that case is 10 milliliters. The ruler, specifically the metric ruler. It's used to measure length and distance. Units of measure are the centimeter, the millimeter, and they have a number of markings on them. Each small marking, unnumbered line, is a millimeter. Each numbered line represents a centimeter. So between 11 and 12 there we have 1 centimeter. Each unnumbered line is a millimeter. And also just pay attention to that little important note down at the bottom of the slide there. This is only a portion of a ruler. So there are 10 millimeters in 1 centimeter. So that's important to know when we start doing some conversions. Alright. How to use a ruler. Step 1, choose an object to measure and place it on a flat surface. Step 2, align the ruler to the side of the object with the beginning of the object at the 0 mark. Be careful, some rulers have the 0 at the end of the ruler. Some rulers have the 0 in just a little bit. Locate the opposite edge of the object and read the last number on the ruler where the object ends. So what is the length in millimeters and in centimeters of the object that we have right here? So if we're looking at millimeters, it's going to match up right there. Looks like 1, 2, 3, 4, 5, 6, 7 marks past the 3. So in this case it would be 10 for the 0 to 1 mark, 10 millimeters. From 1 to 2 would be another 10. From 2 to 3 is another 10, so we're up to 30. Plus 7 more gives us 37 millimeters. Or 3.7 centimeters. So we aren't quite to 4 centimeters. We're a little bit back. We're still under the 3's area. In this case, we're at 3.7 centimeters. So what's the relationship between our two answers? That's something for you to think about for a little bit. We'll talk about that a little bit later. The standard ruler, it's used to measure length and distance. The units of measure are the inches and feet. The markings in this case, the smallest markings are 1/16 of an inch. The larger markings, the ones that are slightly larger than 16th, are 1/8 of an inch. The ones that are slightly larger than the 1/8 of an inch marking are 1/4 inch markings. And then the next largest one are the 1/2 inch markings. And then finally the numbered ones are inch markings. So parts of an inch. 1/16. We're going to break this down, kind of make a little bit better sense out of it. This is obviously enlarged to help you out. So there are 16/16 in 1 inch. When you see a fraction, it's saying 1 of 16 if you're seeing 1/16. There are 16 of them in 1 inch. Eighths. For every 2/16 we equal an eighth. Fourths. For every 2/8 we get a fourth. Two halves. There are only 2 halves in an inch. So we're going to combine each part. We're going to try to make a little bit better sense out of what we see on a ruler by looking at this animation here. So the 16ths come down. The 8ths come down. Fourths come down. The 1/2 comes down. So in each inch we have 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, and then an inch. So in order to use the ruler, choose an object to measure and place it on a flat surface. Align the ruler to the side of the object with the beginning of the object at the 0 mark. Again, be careful, some rulers have 0 marks at different spots, so pay attention to where the 0 mark is. Locate the opposite edge of the object and read the last number on the ruler where the object ends. So what is the length in inches of the object below? Round to the nearest 16th of an inch. So in this case, we've got 1 in 7/16 inches. Here's 1. Here's 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, and 7/16. It's closest to 7/16. My red line's moved over to the right slightly. Alright, meter sticks. They're used to measure length and distance. The units of measure are the meter, centimeter, and millimeter. So this right here is just a portion of a meter stick. You can get the general idea. Each individual numbered line is a centimeter. There are 100 centimeters in a meter. Don't forget that there are 10 millimeters in a centimeter. So 10 times 100 equals 1,000. There are 1,000 millimeters in a meter. Each small unnumbered line is a millimeter again. So each line is a millimeter. Each long line followed by a number is a centimeter. 10 millimeters, there are 10 millimeters in a centimeter. There are 100 centimeters in a meter. So again, how many millimeters are there in a meter? There are 1,000. So how to use a meter stick. Choose an object to measure and place it on a flat surface. Align the meter stick to the side of the object with the beginning of the object at the 0 mark. Be careful, some meter sticks have zeros at different locations. So pay attention where the 0 mark is. It might be slightly indented. Locate the opposite edge of the object and read the last number on the meter stick where the object ends. So how long is this book? Looking at this book right here. There's my line. So we're after 24 but before 25. In this case we are 0.246 meters or 24.6 centimeters or 246 millimeters. All of those numbers are equivalent. They equal the same. A tubular spring scale, used to measure weight. Units of measure are the Newton or the gram, and they are dependent upon gravity. So a spring is basically the resistance that is used in this just to measure. They come in a variety of measurement capabilities. They could be 100 grams. They could be 50 grams. They can be 10 grams. And usually there's some different colors on there that indicate different types of tubular scales. So some of them come in different colors, and I believe that's the way our lab ones are. We have a variety of colors that indicate what type of tubular scale they are. The value of the graduated markings or lines, they vary with every spring scale, so again you got to pay extra close attention to that. Using a spring scale with the smallest possible capacity is going to allow you to make a more accurate measurement. The ring at the top, sometimes those are just held onto, sometimes they're hung up on another object. If you've ever used a spring scale to weigh a deer that maybe has been harvested, or maybe you're at the fair and you're a student that does 4-H and you do like a carcass hog or something like that, a lot of times they'll use a type of spring scale where they just hang it up on a hook, and then your carcass animal hangs off of the bottom hook. There is an adjustment knob. The adjustment knob really shouldn't need to be moved very often for ours. There's a pointer. The pointer helps to identify the actual weight, and then the graduated markings give you the specific weight. And finally, the object hangs off the hook. So how to use: select a spring scale with the smallest possible capacity that can accommodate or measure the weight of your object. Determine what scale you will be using, newtons or grams. Similar to when using a graduated cylinder, determine the value of each graduated marking or line found on the scale, and knowing that will help you determine the weight. Hang the ring of the spring scale on a sturdy object, such as a ring stand with a clamp, or maybe there's a hook that you can hang it on. You will then determine the pointer, if the pointer is at the 0 mark. If it is at the 0 mark, you may move on to step 7. If it's not at the 0 mark, you need to complete step 6. And again, should always be done at eye level. Step 6, zero the spring scale by turning the adjustment nut at the top clockwise to raise the pointer, and then counterclockwise to lower the pointer. The nut should be adjusted until the pointer is at the 0 mark. Carefully hang the object on the hook. Measure the object's weight by reading where the pointer falls on the scale, and again, should always be done at eye level. So what weight in newtons is being displayed by the spring scale? You can see over here on the left-hand side where it has newtons. On this side it says grams, I do believe. I just think the G's kind of covered up. So in this case, if it wants to measure in newtons, right here is the top of that spring scale and where it's falling at. So since each graduated marking is equivalent to 0.5 newtons, the weight being displayed on the spring scale is 6 newtons. Finally, the thermometer, used to measure temperature. Units of measure are degrees Celsius, degrees Fahrenheit, and degrees Kelvin. It relies on the expansion and contraction properties of fluids, so as things warm up they expand, as they cool down they contract. Alcohol is used in the newer thermometers. Used to use mercury, but mercury is a toxin, so we can no longer have mercury in the school. So Celsius and Fahrenheit scales, they meet at -40 degrees. So -40 degrees both in Fahrenheit and Celsius equal the same thing. There is a relationship between scales. Degrees Celsius equals 5/9 degrees Fahrenheit minus 32. Or, if you're trying to figure out the degrees Fahrenheit from Celsius, degrees Fahrenheit equals 9/5 degrees Celsius plus 32. So we can use either of these equations to convert degrees Fahrenheit to Celsius or degrees Celsius to degrees Fahrenheit. And then finally, Kelvin, degrees Kelvin. All you have to do to find degrees Kelvin is find the degrees in Celsius and add 273. So how to use a thermometer to determine what scale you will be using, Fahrenheit or Celsius. Similar to when using a graduated cylinder or spring scale, you need to determine what each one of the graduated markings equals. Knowing this will help you determine the temperature. You can set up a ring stand with a clamp on a flat surface, and you'll carefully tighten the thermometer into the clamp. Place the object or the substance to be measured at the base of the ring stand. Lower the thermometer into the object or substance. Be sure not to allow the bulb of the thermometer to sit or touch the container. Sometimes the edges of the containers can get too hot, causing those bulbs to break or causing the thermometer to break. Measure the temperature of the object or the substance by reading where the top of the red liquid or the alcohol aligns with the appropriate scale. And this again should be done at eye level. So what's the temperature in degrees Fahrenheit and Celsius that you see here? It's important to know what the difference is between each graduated marking. So on the left is degrees Fahrenheit, on the right is degrees Celsius. Right there is our line. So in this case we're looking at 74 degrees Fahrenheit because each line equals 2 on the Fahrenheit scale, so I go 72, 74. It is 23 on the Celsius scale because on the Celsius scale each line represents 1.